Hello, we're looking at example number 1 on page 779 of your Pre-Calculus Part 2 textbook. This is graphing a linear inequality with two variables. You can see here that the equation they want us to graph is 2x minus 3y is greater than or equal to 6. Now, one of the options you can have here is to put this in slope-intercept form because that's the way we learn how to graph. If you'll remember, slope-intercept form is y equals mx plus b. So that's one option. The option they're showing you here in step 1, however, is to find the x and the y intercepts. And what you do is you simply take the equation that was given to you from the original. Forget about the greater than or equal for right now. Just think about it as equal. And if you want to find the x-intercept, or where it crosses the x-axis, you're going to make the y value 0. And so that's exactly what they've done in this problem. They made the y value 0 here. And of course, that ends up being 2x equals 6 or x equals 3. Then they come over here and they do the same thing. They take the original equation, and to find the y-intercept, they make the x value 0. So you can see that they plug in a 0 right here for the x value. That's going to leave you with negative 3y equals 6. If you divide both sides by negative 3, then y equals 2. So what you can see that they do here is they plot those on a graph. So you've got x be 3, so that means 3, 0, which is this point right here. And then you've got y equals negative 2, which is 0, negative 2, or that point right there. When you connect those lines, as you can see they've done there in the blue, that is the line that represents 2x minus 3y is greater than or equal to 6. Now, the second thing we have to choose is which side, because it is not an equal sign this time, it's an inequality. It says greater than or equal to. Now, I know that a lot of times this can be a little tricky because in my mind, I think of greater than always being above and less than being below, but you really do need to test a point that's not on the line so that you can see which side of the line that's going to actually get shaded. And that's what step 2 is really trying to tell you to do here, is to test a point. The origin is the easiest point to test because you're plugging in zeros, and so that would be the easiest point, and that's the one they tend to use a lot. So that's what this next part is right here. If they plug in 0 for the x and the y, they're using that as our test point, then we end up with 0 is greater than or equal to 6. Well, this statement is not true. 0 is not greater than or equal to 6. So therefore, I'm not going to shade the side that 0, 0 is on, which would be this side. I'm going to shade the other side of it, which, because I tested 0, 0 on that side didn't work, then I shade the other side, as you can see that they've done right here. Okay, and that's what step 3 is trying to say, that if you find out that the side the 0, 0 was on, if that ends up being false or is not true, then you shade the other part. If that had been true, then we would have shaded the side that the 0, 0 was on. Okay, so let's try another one on our own. If I want to find the x and y intercepts, I'm going to take 4x minus 2y equals 8. Remember, when we're doing this part, we don't worry about the greater than or less than. I'm going to plug in to find the x-intercept, I'm going to plug in a 0 here, which is going to make this 0. So I end up with 4x equals 8, which means that x ends up being 2 there on that particular problem. And then as well, if I take the 4 and I plug 0 in for the x value this time and solve for the y, I'll be able to find my y-intercept. That's going to be minus 2y equals 8. So y is going to end up being negative 4. Okay? So if I were to graph this here, and I'm just going to sketch it, you've got x equals 2, which is going to be right here, and you've got y equals negative 4, which is on the y-axis down here at negative 4. So it is a line that's going right up through here. And again, because there is an equal line under right here in the original, that means that's going to be a solid line. If that were just greater than, then you would put a dashed line if there's not an equal sign there. Equal means solid, and if there's not an equal sign there, you would make a dashed line. Now, I need to decide which side I'm going to shade. So again, I'm going to test 0, 0. Well, if I plug 0, 0 into this equation, 4 times 0 minus 2 times 0, is that going to be greater than or equal to 8? Well, that ends up being saying that x is greater than or equal to 8, and that is not true. So I'm not going to shade the side that 0, 0 is on. Rather, I'm going to shade the side that 0, 0 is not on, which is this side over here. So I end up shading that particular area over here. And that's the way you graph a linear equation. All right? Hope this helped.